Welcome to the world of building automation. In this chapter, we will delve deeper into the types of signals used in building automation. There are two main types, digital and analog signals. Digital signals are binary, meaning they have only two states, on or off. These are often used for simple on-off control tasks. On the other hand, analog signals can vary continuously and are used for more complex control tasks. Let's explore some common types of analog signals used in building automation. Welcome to the world of building automation. In this chapter, we will delve deeper into the types of signals used in building automation. There are two main types, digital and analog signals. Digital signals are binary, meaning they have only two states, on or off. These are often used for simple on-off control tasks. On the other hand, analog signals can vary continuously and are used for more complex control tasks. Let's explore some common types of analog signals used in building automation. Welcome to the world of building automation. In this chapter, we will delve deeper into the types of signals used in building automation. There are two main types, digital and analog signals. Digital signals are binary, meaning they have only two states, on or off. These are often used for simple on-off control tasks. On the other hand, analog signals can vary continuously and are used for more complex control tasks. Let's explore some common types of analog signals used in building automation. Analog signals come in various forms. One common type is the 0-10V signal, which varies voltage to represent different levels of a parameter. Another is the 4-20 mA signal, which uses current to represent parameter levels and is less susceptible to signal loss over long distances. RTD, or resistance temperature detector, is a type of sensor that changes resistance with temperature, providing precise temperature measurements. Understanding these signals is crucial for effective building automation. But why is this important? Well, imagine trying to control the temperature in a room. The 0-10V signal can tell a thermostat to gradually increase the heat, while a 4-20 mA signal can do the same but more reliably over long distances. The RTD can then provide accurate temperature feedback to ensure the room stays comfortable. These signals work together to create a seamless, automated environment. In essence, mastering these signals is the foundation of any smart building system. They are the unsung heroes that make modern conveniences possible. Now let's move on to see how buildings themselves communicate through these signals. Now let's move on to analog signals. These signals are quite different from their digital counterparts. Unlike digital signals that have only two states, analog signals can have many possible values. They can represent a whole range of information, not just a simple on or off. Think about a dimmer switch for a light in your dining room. You can adjust it to make the light a little bright, very bright, or any level in between. This continuous range of adjustment is what analog signals make possible. They offer much more finesse. Analog signals provide much more detailed and nuanced information. Consider a temperature sensor in a room. It uses an analog signal to report the exact temperature. It can indicate that the room is 20.3 degrees Celsius, 21.5 degrees, or any other value within its measurement range. This is far more precise than a digital signal which might only say too hot or too cold. This precision allows the building automation system to make much finer adjustments. It helps in maintaining a very stable and comfortable environment for occupants. These versatile signals can represent any value within a continuous range. Section 5. The senses of a smart building. Input devices. For a building automation system to work effectively, it needs to know what's happening. It needs to be aware of the conditions both inside and outside the building. This is where input devices come into play. Input devices act as the senses of the smart building. They are like the eyes, ears, and even the skin of the building. They diligently gather all sorts of information from the surrounding environment. They are constantly monitoring various parameters such as temperature, humidity, light levels, and whether people are present. This information is vital. What kind of information do these input devices typically gather? They can measure a wide array of things. Temperature sensors measure how hot or cold it is. Humidity sensors measure the amount of moisture in the air. Light sensors, also known as photocells, measure the intensity of available light. Occupancy sensors detect if people are present in a room or a specific area. Some input devices even monitor if a window or door is open or closed. All this collected information is then converted into electrical signals. These signals are sent to the brain of the system. The brain of the building automation system is typically a controller. This controller needs reliable data from the input devices to make informed decisions. Section 6. Meet the input crew sensors and switches. Let's get to know some of the most common input devices you'll find in a smart building. Sensors form a very large and diverse group within input devices. Temperature sensors are perhaps the most ubiquitous. They continuously tell the HVAC system the current temperature. This helps maintain our desired comfort levels. Occupancy sensors detect whether people are present in a room. They help save energy by adjusting lights and HVAC settings. These sensors use technologies like passive infrared, PIR, or ultrasonic waves. Light sensors measure ambient light, usually natural daylight. They inform the system if it's a bright sunny day or a dark overcast one. Section 7. The brains and brawn control devices. So, we've learned that input devices gather information and convert it into signals. What happens to these signals next? The information they carry is sent to control devices. You can think of control devices as the brains of the building automation system. They are responsible for making all the important decisions. They analyze the incoming data from the input devices. Then, based on pre-programmed logic and set points, they decide what action needs to be taken to maintain comfort, efficiency, or safety. They are the intelligent core of the system. The primary control device in most modern building automation systems is called a controller. Often you'll hear it referred to as a DDC, which stands for Direct Digital Controller. Essentially, a DDC is a small, specialized computer. It runs sophisticated software programs. These programs contain the operational logic for the building systems. This logic is often a series of if-then-else statements. For example, if the room temperature is below the set point, then turn on the heater. Section 8. Smart Buildings in Action Real-World Magic. Let's paint a picture of how all these components, signals, input devices, and control devices, work together seamlessly. Imagine a typical modern office building. As employees begin to arrive in the morning, occupancy sensors in the entrance lobby and various office areas detect their presence. These sensors immediately send signals to their respective controllers. The controllers, following their programmed schedules and logic, then spring into action. They command the lighting systems to turn on in occupied zones. They also signal the HVAC system to adjust temperatures from nighttime setback levels to comfortable daytime set points. Throughout the busy workday, temperature sensors in different zones of the building continuously monitor the thermal conditions. If a particular area, perhaps a sunny meeting room, starts to get too warm, the local temperature sensor reports this to the controller. The controller processes this information. It then commands the cooling system to counteract the temperature rise in that specific zone. This might involve instructing an actuator to open a valve, allowing more chilled water to flow to that area's cooling coil, or it might increase the speed of a variable air volume (VAV) box fan. All this happens automatically without manual intervention. Section 9. The future is automated. What's next? Building automation is transforming how our buildings operate. The future of smart buildings is even brighter and more exciting. Technology in this space is constantly evolving. Systems are getting smarter, more intuitive, and interconnected. We can look forward to more responsive and sustainable buildings. The potential for improvement is vast. Greater integration between different systems is coming. Systems will increasingly talk to the wider energy infrastructure. Imagine buildings adjusting energy use based on real-time prices, or optimizing on-site renewable energy sources. Grid interactive efficient buildings will manage energy resources. They will help create a more stable and sustainable energy future. AI and machine learning will play a huge role. AI can analyze vast amounts of data collected by the BAS. They can learn the unique operational patterns of a building.